Okay, this is Math 123 review for test 4. So test 4 is comprehensive, but more than half of the questions will be from Unit 4. And the other difference is that there will be more questions and you'll get 2 hours to do it. So number one, answer the following questions. 25% of 76 is what? And you can just directly translate that, the 25%, just write as a decimal. The of turns into multiplication, and the 76 stays as it is. So I get 19. Okay, what percent of 80 is 12? So again, we can, if we want, translate that. So what percent is unknown, x, of is multiplication, 80 stays 80, is turns into an equals, and then 12. And then you can see, oh, well, you just divide both sides by 80. So then my unknown is 12 over 80. So at first I get a decimal, and then I can convert that into a percent. Okay. Uh, Now, I did show you another way using proportion. So if you want to see what the setup for the proportion version looks like for each of these. So for the first one, if we set up the proportion, uh, you get that free space, 100, and then 25%. Well, the 25 goes over 100, and then it's is over of. So is what? That's x. Of is the 76, and then you just cross multiply. So we have 100x equals 25 times 76, and then divide both sides by 100. So then we have x is 19 again. So this is the alternative. Now, proportions isn't so bad if you want to do it that way for the rest of your life. But sometimes you have these easy ones where it's literally just you just had to multiply those. So, uh, you know, use your best judgment. For unknown percentages, this method is a little bit different in how it works. So for part B, if I set it up that way, my unknown is the percent. So what percent? I don't know. Let's call it X. Of 80 is 12. So is over of. So of 80 is 12. And you don't have to think about it as is over of. You can match up things that should be going together in the style of proportions. So now when we cross multiply this, we have 80x equals 12 times 100, and then divide both sides by 80. So then we get x is 15. Now, this jumped straight into giving us the percent, and if you think about it enough, you can see why. It's because it's the number that's not divided by 100, right? Whereas when we're using the sentence to equation method, we're thinking about all of our percentages as decimals. When we're doing it with the proportion method, all of the percentages, we're actually dealing with the percentage number, and then we just have to slap a percent symbol on it. Okay, I've said all I should probably say for that one. Last year, Rachel opened an investment account with $8,400. At the end of the year, the amount in the account had decreased by 22%. How much is the decrease in dollars? And then how much money was in her account at the end of the year? So how much is this decrease in dollars? So uh, I'm happy if you give me the positive or the negative, but either way, we just need to figure out 22.5% of the 8,400. So convert that to a decimal and multiply. So it's a $1,890 decrease. And then how much money was in her account at the end of the year, at the end of last year. So I'm going to take this 8,400 minus the 1,890. And I get 6,510. So if it says decrease, I expect my final, answer in part B to be smaller than 8,400. And there's all kinds of ways that you could have done this. The last part, you could have also just taken, and if we were jumping straight to part B, this is what I would have actually done. And then you would also still get the 6,510. Okay. The price of a cup of coffee has risen to $2.50 today. Yesterday's price was, I'm sorry, $2.50. Yesterday's price was $2.15. Find the percentage increase. Round your answer to the nearest tenth of a percent. Okay. So find the percentage increase. So that's a relative change, which is that formula I said would never go away. New minus old over old. So go through and look at this. So today, yesterday. So this $2.50 is the new. Yesterday's $2.15 is the old. So I have 250 minus 215 divided by 215. Okay, to the nearest tenth of a percent. And I get 16.3%. Okay, and of course that's the increase. A certain a certain medicine is given in an amount proportional to the patient's body weight Suppose a patient weighing 116 pounds required 125 milligrams of medicine. What is the amount of medicine required by a patient weighing 174 pounds? So now we've seen some dosage calculation problems before, but remember, these questions can be from the very beginning of the semester when we were talking about basic proportions. So this is one where all you have to do is set up a proportion, and you can think about it as dosage and weight. And then you can think about, patient A and patient B, or whatever you want to call them. So a patient weighing 116 pounds required 126 milligrams of drug. And, however you want to label this. So this is, milligrams of dosage, pounds of weight. And you could have done weight over dosage, you know, just as long as you're consistent. And then what amount of medicine? And then patient weighing 174 pounds. Oh, that's pounds. So that should go on the bottom. And then my unknown is the dosage, right? What amount of medicine? Well, that's the dosage. Then we just cross multiply. So we have 116x is equal to 126 times 174, and then divide both sides by 116. So I get 189 milligrams. Okay. The table below summarizes the number of children per household for a sample of 43 middle-income families. What is the mean number of children per household? Round your answer to the nearest tenth. Okay, so this is a weighted mean. But at the end of the day, it's still just a mean. So with the weighted mean, all we need to do is add a product column, and then we're going to want totals. And this one, since there seems to be no kind of organization, is a little bit trickier. This is where you can kind of do a little bit of what I like to call social engineering and think about, how the question was written. And right there, they said for a sample of 43 middle income families, that's, same thing as number of households. And you can double check. You'll see that uh, this column adds up to 43. So we don't care about that total. And also, even better, you think about what the question is actually asking. What is the mean number of children? So the number of children is what we're trying to find the average of. So just looking at this column, and we can see that it's not in nothing is in any kind of order, but I would have ordered this like, 1, 2, 3, 4, 5, 6, and then we would have just had 0 for one and 0 for 5 children for the frequency on the left. But, oh well. Anyhow, uh, product, we're going to multiply these guys out. So I get 32, 30, 45, and 30. So then 7, 137. So then my mean is going to be 137 over 43. Okay, and I get to the nearest tenth, 3.2. Now the sanity check is, so sanity check. Does my answer make sense, in other words? Your average value, so your mean should be between uh, the lowest number of children, which is 2, and the highest number, which is 6. And we can see, yeah, that passes the sanity check. So it's required that the average is no bigger or no smaller than the smallest thing and no bigger than the biggest thing, right? It's got to be between the smallest and the biggest. If it's outside of that, then your average makes absolutely no sense because your average is something that's supposed to be in the middle somehow. So, and if it's not in the middle, then it's you got some nonsense. So that means you need to go back and recheck your numbers. Okay, using this set, what is the mean of this set? What's the median? What are the modes? So for the mean, all I'm doing is I'm adding these up as is. Well, pretend that was a decimal. It's too much work to go in and erase it. So I have all of these added up, and then I'm dividing by the number of things. I have 1, 2, 3, 4, 5, 6, 7, 8 things. So I have 3,686 divided by 8. So to the tenths, I'm getting 460.8. Okay, the median. So I have to actually sort this. So I go through and I find the smallest thing. So 310, and then, I'm sorry, 301. Wow, 301, then 310, and then 311, 343, 472, 514, 664, and then 771. And then 1, 2, 3, 4, 5, 6, 7, 8. All right, so I still have my 8 things. And then you can use your fingers to work your way to the middle. So I just need to find the middle. And I can see in this case, I have two things in the middle. So now my median is going to be the mean of those two things in the middle, since I have an even number of objects. Okay, so I just add them up and divide by 2. Okay, so then that's 815 over 2, which is 407.5. Okay, forgot to put a box around that one. Okay, then what are the modes? Since this was sorted, um, any duplicates should be right next to each other. In this case, there are no duplicates. And I almost I kind of saw that 301 as a 310 at first, unfortunately. So I almost saw a duplicate that wasn't there. So it's really hard to look at data uh, as a person, especially if there's a lot, which is why we use computers for large data sets. But we have to, understand at a fundamental level how these things work, and then we can scale it up. Okay, so what's the mode? There's no repeats, so there is no mode. So none or no mode or whatever. Okay, in late August of last year, Pi D Restaurant sponsored its first pizza eating contest. For the contest, the number of slices of pizza eaten by each contestant uh, were counted. The histogram below summarizes the data. Use the histogram to answer each of the questions. So this is optional, but I'm going to go ahead and just label these so I don't have to think so hard later. Okay. First question. What is the class width? So for the class width, you want to take the uh, the class boundary on the left for the first two classes and just subtract. And it could be any consecutive classes. So I could do, 11 minus 6, or I could do, or I could even do 10 minus, or 15 minus 10, or I could do 16 minus 11, whatever. Um, it's 5. Please don't be off by 1. I believe in all of you. Sometimes it's easier to look at the upper boundary. So, 10 to 15 to 20 to 20. So it's counting up by fives. Okay. One class is the least frequent. How many contestants are in this class? So the least frequent is 10 to 15. How many contestants are in this class? So 2 contestants. All I'm looking for, all that's actually being asked for is that 2. How many contestants ate 16 or more pizza slices? Okay. 16 or more. Well, I have 16 to 20, but they could have also eaten 21 to 25, right? That's what our data has. So 16 or more, that means that I have to combine the 16 to 20 and the 21 to 25. So in other words, I'm just taking the 5 plus the 3, and I get 8. A biologist is studying rainbow trout that live in a certain river, and she estimates that their mean length is 572 millimeters. Assume that the lengths of these rainbow trout are normally distributed with a standard deviation of 25 millimeters. Use a standard normal table provided at the end of the packet, uh, the test, to find the percentage of rainbow trout in the river that are shorter than 602 millimeters. Okay, so we have the mean is 572. The standard deviation is 25. We're looking for shorter than 602. So our x is 602. And if it's shorter than, then that's the area to the left. And if it's the area to the left, then it's the area straight off the table. Okay. Well, we need our z value. So remember, z-score is the data value or data item minus the mean divided by the standard deviation. And on your formula sheet, you should have something like z equals x minus mu over sigma, or x minus x bar over s. So we have 602 minus 572 over 25. So I have 30 over 25, and I get 1.2, but you'll want to rewrite that as 1.20 for when you look that up. So now the area corresponding to a z-score of 1.20, let's look that up. So I have 0.8849. Okay, and it asks to find the percentage. So we already concluded that it's the area to the left, which is the number straight off the table. So we don't have to do anything special to this other than convert it to the percent. So 88.49% of rainbow trout in the river are shorter than 602 millimeters. The sugar sweet company is going to transport its sugar to market. It will cost $7,500 to rent trucks, plus $175 for each ton of sugar transported. The total cost, C, in dollars, for transporting in tons is given by the following. C equals 7,500 plus 175 in. Answer the following questions. What is the total cost for transporting 13 tons? So N is tons. So this is telling us that N is 13. The other contextual clue here is what is the total cost? In other words, they're asking what's the C value. So now we can use this function or this equation that represents a function, and we just plug in 13 for n, and then it just turns into an arithmetic problem. We just have to calculate something. So then this is 7,500 plus 2,275. And then we end up with 9,775. So $9,775. The next one says, if the total cost is $11,700, how many tons is the company transporting? So now you can see they're giving us a dollar value here. They're even calling it the total cost. So they're telling us that C is this 11,700, and it says how many tons. So I don't know. That's what we're trying to find. So now we have our equation that relates C and N. And what we're doing now is we're substituting this 11,700 in for C. And then we're going to solve for N. So now this one's a little bit harder because we have to do 2 steps of algebra. So I'm going to subtract the 7,500 from each side of the equation. So I have 4,200 on the left-hand side and 175 on the right-hand side. Then I'm going to divide both sides by the 175. So I get 24 is equal to N. So we have 24 tons. Okay, number 10, the dollar value V of t for a certain car model that is t years old is given by the following exponential function. V of t equals 25,900 times 0.90 raised to the t. What is the initial value of the car? You just read that straight off of the function. So we get this $25,900. What is the value of the car after 11 years? So t is measured in years, so we set t equal to 11. We're finding v of 11. So this is going to be 25,900 times 0.90 raised to the 11. Okay, and we're going to round that to the nearest dollar. I get 8,128. $8,128. A bank offers an investment account with an annual interest rate of 1.39% compounded daily. Keith invests $3,800 into the account for 5 years. Answer the questions below. Round answers to the nearest cent. Assuming no withdrawals are made, how much money is in Keith's account after 5 years? So compounded daily is telling us that N is equal to 365. Practically every interest rate that you're ever given in this class is an annual or a yearly interest rate, and um, don't don't be confused by that. Um, there's only one situation that we actually use in this course where they give you something other than that, which is that monthly interest rate when we're doing the credit card stuff. But other than that, uh, the divide by 365 is built right into the formula that we're about to use. So keyword compounded. Okay. And then when it says anything other than compounded yearly or compounded annually, we're using that general compound interest formula. So A equals P times the quantity of 1 plus R over N raised to the NT. Okay, so he's investing 3,800, so that's our P. Uh, the interest rate was 1.39%, but we have to convert that to a decimal. And like I mentioned before, sometimes you might not want to trust yourself too much during the test. There's no shame in dividing that by 100 just to be sure that you're converting that to a decimal correctly. Okay, number of compoundings per year is 365 since it's daily. And then it was for 5 years. So how much money was in his account after 5 years? We're about to find out. Okay, that's just going nuts there. Oh no, skipping around on me. Times 5. Okay. Okay, to the nearest cent, I'm getting 4,073.49. So that's $4,073.49. Okay, then how much interest was earned? So when we're doing compound interest, we can find the total value, the total future value, A, or total future amount, um, using that formula. And then to get the interest, we take that future amount minus the principal. So we're going to take that $4,073.49 and subtract the $3,800. So I get $273.49. Okay. All right. If you see a problem like this with the conversions, uh, each piece here is worth points. So make sure that you fill this in correctly. Okay. So all of these are worth points. They're all worth points. Make sure you fill them in. Okay. A swim race has a total distance of 30 miles. Race officials want to mark the course every 825 yards with a buoy, including one at the finish line. The starting line does not need a buoy. How many buoys are needed? Um, just assume that this question is engineered so that you could just do a basic unit conversion and you don't have to think too hard about it. So first fill in the blanks on the left side of the equation using three of the ratios shown, and then write your answer on the right side of the equation. Each one of these ratios is formulated correctly. You just have to use the correct ones. So uh, we're going to take miles and convert it to buoys. And the last thing they said about buoys is yards. So we can go from miles to feet to yards to buoys. So first I'm going to go from miles to feet. So I'm still thinking, well, what I'm canceling out miles, so I want the one with miles on the bottom. So I'm going to use this one. So 1 mile, 5,280 feet. Okay. So now you can see that miles cancel out. And if it helps you, you can still cancel it out on the test. And then I want to cancel out feet and go to yards. So now let's see. That would be this one. So 3 feet and 1 yard. And now you can see the feet cancel out. And then last, I want to cancel out yards and go to buoys. So that's going to be this one. So 825 yards for every buoy. And then I'm just going to multiply this out. So you can multiply across the top. And you can multiply across the bottom. And really, all I actually end up typing into my calculator is something like this, at least with one way that I might do it. So this is a step that you don't really need to write down. It's kind of a thinking step that I'm writing down for you so you can see the thought. So all those multiplied by ones, you don't need to type those in. They're unnecessary. What really needs to get typed into your calculator is something like this. If you're feeling uh, brave and confident, you could even just do something like this. And on most models of calculator, especially the Texas Instruments ones, this will work out uh, correctly. So that's a multiplication. And if you are doing it this way, uh, highly recommend you wrap parentheses around the top of the fraction and you wrap parentheses around the bottom of the fraction. Once you become more of an expert in order of operations, you can see which set of those parentheses are unnecessary and which ones are absolutely necessary. Okay, so however you get there, I'm getting 64 buoys. Okay, so and then the deliverables. I want to see each one of these, and of course the final answer, and then um, you know any any additional work is optional. Like as far as this question is concerned, all of the work is actually part of what gets graded. That's all the work that you need to show there. Uh, Anything else is just strategizing for how you're plugging it into your calculator. Fill in the blanks. 6 pounds equals blank ounces. So if you look at the formula sheet, 1 pound is 16 ounces. So 6 pounds over 1. And I want to cancel out pounds and end up in ounces. So 1 pound is 16 ounces. So these cancel, and all this was telling me is that I'm taking the 6 times the 16. So I get 96 ounces. Now, I have that blank there in these questions. And if you just write a number and you don't have any work showing and it's wrong, I can't work with that. So make sure you're showing your work for these questions. So 4,000 pounds to tons. So 1 ton is 2,000 pounds. So pounds, tons. So 1 ton, 2,000 pounds. So this is telling me to take 4,000 divided by 2,000. So I get 2 tons. Okay, fill in the blank. 16 fluid ounces equals blank cups. So 1 cup is 8 fluid ounces. So if you have 16 fluid ounces, so cancel out ounces, go to cup. So 1 cup, 8 ounces. So this is telling me to take 16 divided by 8, so I get 2 cups. Okay, gallons to quarts. So 1 gallon is 4 quarts. So 6 gallons over 1. Cancel out gallons, go to quarts. So 1 goes with gallon, 4 goes with quarts. So I can see that I'm taking the 6 times the 4, so I get 24 quarts. Okay. Ahmed is on the swim team. Each day he swims 750 meters. How far is this in kilometers? So kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters, which you can get all of this off of that formula sheet. So we're going from meters to kilometers. 1, 2, 3 to the left. So I write down my 750. My decimal point is implied to be there. 1, 2, 3, and then there's my new decimal point. So then my final answer is going to be 0.75 kilometers, which just makes it sound like he went so far, but they're the same length. An aquarium tank holds 65 gallons of water. How much is this in liters? Round to the nearest whole number. Okay, so if we want to go from gallons to liters, so gallons, that's in English units, liters, that's metric. So we'll want to take a look at the formula sheet, and we want to look at the English metric equivalents. So we have 1 liter is approximately 1.06 quarts is our connection. Okay. And then we also need to know that 1 gallon is 4 quarts. So then we start with the 65 gallons, and we're going to cancel out gallons and go to quarts first. So 1 gallon is 4 quarts. So gallons are done. And then next we want to go from quarts to liters. So 1 liter is 1.06 quarts. So then these can cancel out. And you can see the final thing that we have there is where we want to end up, liters. So we don't have to go any further than that. So I can see I'm taking 65 times 4 and then dividing that by 1.06. So to the nearest whole number, this is 245 liters. Okay, a science fair poster is a rectangle 48 inches long and 36 inches wide. Some of the entry rules for the fair refer to the area of the poster in square feet. Calculate the area in square feet. To be quite honest, you could just convert these to feet first. Uh, but I'll just kind of set this up however I like. So 48 inches times 36 inches. That's the area. And my conversion factor, I can cancel out inches and go to feet. And then, of course, 1 foot is 12 inches. And I can see that that's just canceling one of these out. So if I want to cancel them both out, I need to square the conversion factor. Okay. Or I need to repeat it. Either way. So what this ends up being is 4 feet times 3 feet. You could have just jumped straight to 12 if you wanted, just to plug all of that right into the calculator. So I end up with 12 feet squared. A kitchen has a tabletop that is a rectangle, 91 centimeters. Let's see. Okay. 91 centimeters long and 61 centimeters wide. Anne is an interior designer and wants to cover the tabletop in small tiles. She knows the area of each bag of tiles, what it covers, but only in square inches. Find the area of the tabletop in square inches, round to the hundredths. So in this one, I can go straight from centimeters to inches. So from the formula sheet, 1 inch is 2.54 centimeters exactly. So then my area, it's 91 centimeters times 61 centimeters, right? Length times width. And then I want to cancel out centimeters and go to inches. So 1 inch is 2.54 centimeters, and I'm squaring this conversion factor. So to the hundredths place, I have 860.41 inches squared, or square inches, however you want to say it. So she wants to cover the tabletop with tiles. She doesn't have any to begin with, and she can't buy partial bags of tiles. Each bag of tiles covers 64 square inches. How many whole bags of tiles does the designer need to buy to completely cover the tabletop? So we can't buy partial bags. So one bag gives me 64 square inches or inches squared. So if I am starting with 860.41 square inches, well, I can cancel out that and go to bags. So one bag is 64. So now the inches squared just completely cancel out. And keep in mind, that square was just on the unit. There's no squaring operation in this particular conversion like there was in the last one, where I squared the conversion factor. So in this one, I am just taking the 860.41 divided by 64. Okay, so I get approximately 13.4 bags, but I have to round this up to 14 bags since I can't buy a partial bag. Okay, each bag costs $4.23, so one bag equals $4.23. How much will she spend on tile? Round to the nearest cent. So I have 14 bags that I need to buy. A bag and money, right? So I'm canceling out bags, going to dollars. So one bag is $4.23. So bags can cancel out. So, so I'm taking 14 times 4.23. And I'm just, emphasizing unit conversions. This last one, if you just want to use your good old common sense to figure it out, that's perfectly fine. Diane is ordering 5 bags of cat food from Canada. Each bag has a mass of 6 grams. To determine shipping costs, Diane needs to know the total weight in pounds. What is the weight of the cat food in pounds? So 1 kilogram is 2.2 pounds. So if I have 6 kilograms, I want to cancel out kilograms and go to pounds. So 1 kilogram is 2.2. So I'm multiplying the 6 by the 2.2. So 13.2 pounds. Okay. Oh, wait a second. That's just what is the weight of the cat? I forgot she's ordering 5 bags. Oh no, right? So uh, we can just take this times 5. So I get 66 pounds. All right. That's not my favorite. If I was honestly, if I was setting this up from the beginning, it'd be like 5 bags and then cancel out bags and go to pounds. So one bag was 6 kilograms. So I can't do that. So I'm going from bags to kilograms first. So one bag is 6 kilograms. And then kilograms to pounds. And then I get my 66 pounds. All right, that's the way I would have done it had I been remembering the 5 bags from the start. Okay. A six-sided die labeled 1 through 6 will be rolled once. Each number is equally likely to be rolled. What is the probability of rolling a number greater than 2? So we can recall that our sample space Okay, I'm trying to get rid of the bad. Our sample space is 1, 2, 3, 4, 5, 6. The event is numbers in the sample space that are greater than 2. So 3, 4, 5, and 6 are greater than 2. So then the probability of our event E, it's the number of things in E divided by the number of things in the sample space. So we have 4, 6. So as a reduced fraction, that's going to be 2/3. Okay. Suppose a company needs temporary passwords for the trial of a new payroll software. Each password will have 2 letters followed by 1 digit, followed by 1 letter. The letter W will not be used, so there are 25 letters and 10 digits that will be used. Assume that the letters can be repeated. So that's important to know. How many passwords can be created using this format? So let's see, what did it say? 2 letters followed by 1 digit followed by 1 letter. So that's the trickiest part of this. Make sure that you're paying attention there. Um, so for that first spot, I could put 25 letters, and if letters can be repeated for the next spot, it's 25 letters. And then they said 10 digits, and then one more letter, and letters can be repeated. And then all you're doing is you're multiplying these. So I get 156,250. See, on a banquet table, 11 different dishes of food will be placed in a row. There are 6 vegetarian and 5 meat. They will be placed in alternating between the 2 types of dishes. Vegetarian will be first. How many ways are there to place the dishes on the table? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. And it's going to be vegetarian meat all the way through. So I put my first vegetarian dish down. So there's 6 to start with. And then I put my first meat, and there's 5 meat to start with. And then when I get to my next vegetarian, I've put one down. So now there's 5 left. And then I put 1 meat down. So there's 4 left. And then I just keep going until I run out in this case. And then what am I doing with all these numbers? I'm going to multiply them. So I get 86,400. Okay, and I will say I didn't type that in my calculator like that. I just typed this into my calculator, but that's a secret. Okay, so that was the secret calculator shortcut I used, but you're not supposed to know that, so you didn't see that. Okay. In Bill the Boring's dryer, there are 6 gray shirts, 10 black sweaters, and 3 gray sweaters, but there are no black shirts. Bill is going to take one of these pieces of clothing out of the dryer at random to check if his clothes are completely dry. What is the probability that the piece of clothing Bill takes out is black or is a shirt? Round your answer to the nearest hundred. You can still make the table. So we have mutually exclusive things, right? So in at least in a sense, right? So We're distinguishing a shirt from a sweater. Like, let's assume that means, just like a t-shirt. And then we're distinguishing gray from black. And we're going to want total and total. So we have 6 gray shirts and we have 10 black sweaters and 3 gray sweaters, and there are 0 black shirts. So then we have 6 shirts total, 13 sweaters total, 19 articles of clothing total. Okay. And we can see the bottom row so matches. Now the question takes out, is it black or is it shirt? So black or shirt. So at the end of the day, it's just the number of black or shirt divided by the number of things in the sample space. So black, that's these ones. Shirt, that's these ones. So I just do 6 plus 10 over the total number of things, which is 19. Or you could say, 6 plus 10 plus 0, but that's why it's just 6 plus 10. Uh, Now, once you made the table, or if you made like a Venn diagram out of this or something, you could clearly see, what's mutually exclusive and what's not. But we didn't really have to think too hard about it when we made the table. So we got 16 over 19. And okay, it said to the nearest hundredth, so that means I have to do one more thing. So punch it into the calculator. So I get approximately 0.84. Of the people who fished at Clearwater Park today, 63 had a fishing license, 27 did not. Of the people who fished at Mountain View Park today, 48 had a license, 32 did not. No one fished at both parks. Aha, they're mutually exclusive. Suppose that one fisher from each park is chosen at random. What is the probability that the fisher chosen from Clearwater did not have a license and the fisher chosen from Mountain View had a license? Uh, so Clearwater, I'm going to call that uh, CLP, and Mountain View, I'm going to call that MVP. So we have the Clearwater Park and then the Mountain View Park, and then we want to have total, and then license versus no license. So if you have a license, that's mutually exclusive with not having a license. And if you don't have a license, that means, so these are mutually exclusive things, and we want a total for that. Okay. All right. So Clearwater Park, 63 had a license, 27 did not. I can see that those add up to 90. And then Mountain View, 48 had a license and 32 did not. And I can see that those add up to 80. So we're looking at 170 people total. And then if I add these up, I get 111. And if I add these up, I get 59, and I can see that these also add up to 170. Okay, so probability that the chosen fisher, okay, so we're taking one fisher from each park. So these are independent events. Uh, so I can kind of write this out the long way, uh, but I'm not going to. But what I'm trying to say is that this and this, these are independent. And then the fact that we're using the and means that we're going to multiply the probabilities. That's supposed to say probabilities. Okay. So Clearwater Park did not have a license. So that's going to be 27 over 90. And then Mountain View had a license. So we're just going to multiply. Since they're independent events, I can just multiply the individual probabilities. So had a license from Mountain View, that's 48 over 80. Okay, and then I multiply these out. So as a decimal, this comes to 0.18. Okay, Dr. Cox is a veterinarian who sees only cats and dogs. In each appointment, she may or may not give the animal a vaccine. The two-way frequency table summarizes Dr. Cox's 60 appointments last week. And let's fix this table. It looks a little broken. There we go. Oh, that's much better. Okay, so now we have our totals and our grand total. So let's see. So no vaccine means that they uh, had that appointment and didn't get a vaccine. Cat is the appointment involved a cat. So the probability of cat, it's just the number of cats over the number of appointments total. So there's 30 cats, there's 60 appointments in our sample space. And as a decimal, that's just going to be 0.5. So no vaccine and cat. So then that's the number of appointments where it's no vaccine and cat over the total number of appointments in the sample space. So now, and so here's cat, here's no vaccine. If it's the and, then we just want where they meet up. So both of them have to be true. So it's a cat appointment and no vaccine appointment. There's only 12 appointments that fit that at the same time. Now, if it would have said or, that's when we would be adding these three things up. So just this 12. So no vaccine in cat is going to be 12 over 60. So then we have zero point 0.2. Okay. Now this next one, no vaccine given that it was a cat appointment. So probability of no vaccine appointment given that it was a cat appointment. There's a formula for this, and the formula is the probability of no vaccine and cat divided by the probability of cat. So in this case, well, look at that. We already have those. How about that? So then I get a probability of zero point 0.4. Okay, that being said, you could use that table shortcut for the last one. So no vaccine given it was a cat appointment. So you could just say, well, if it's a cat appointment, then I'm only looking at this row, and the no vaccine number in that row is 12, and the total for that row is 30. So it's kind of the alternative approach for this one. Had we not had those other two numbers just sitting there, um, we would do 12 over 30. And of course, you get zero point 0.4 again. But the way that this question is engineered, it's basically saying, all right, well, calculate this one, and then calculate this last one. And they're just, this is kind of a, if you know the formula, then you know you can just take and divide these answers in the correct way. So we're taking the and probability, dividing by that cat probability. On a particular day, a fitness studio had 174 customers. For each, an employee recorded whether the customer was new and what class the customer took. The data are summarized in the table below. Suppose a customer from that particular day is chosen at random, and then we're going to find some probabilities related to that. Now, with this, again, I want a total row and a total column. So 94, 80. And then I can see that these add up to 174. So then that makes sense. I would certainly hope so. And then 33, 62, 37, 42. And then you can do a quick sanity check and just make sure that those also add up to 174. All right, and then we're rounding all of these probabilities to the nearest hundredth, so I don't have to worry about reducing fractions or anything on this particular problem. What is the probability that the customer was not new, given that the customer took a Pilates class? So now I can just isolate the Pilates, and the number of not new in that column is 11. So it's just going to be 11 over 42. So to the nearest hundredth, I get 0.26. What is the probability that the customer was new? There's no condition here. So then that's just going to be the number of new customers over the total number of customers. So I get 0.54. Okay. A rapid antigen flu test is the least accurate type of flu test. The test accuracy rate is approximately 60%. Assume that 13% of the population will have influenza this year, and we will test 600 people for influenza. Complete the table. So part of the points for these kinds of questions is getting the table correct. So 600 people being tested, 13% will have the flu. So I'm going to take that 13% of the 600. So I get 78 for that one, and then 600 minus 78, and I have 522. Okay. Uh, the test accuracy rate is 60%. So then that's giving us the true positive and the true negative. So I'm going to take 60% of 78. So I get 46.8. And then I can take the 78 and subtract that. So I get 31.2. And then that is my false negative. And then for my true negative, so 60% accuracy, that means that 60% of the people who don't have it will actually test negative like they're supposed to. So 0.6 times 522. So I get 313.2. And then I'm going to take the 522 and subtract that. So I get 208.8. And then just add those columns up to complete the table. So I have 255.6. And 344.4. And those should add up to 600. And they do. Okay, if you test negative for influenza, what is the probability that you do not have influenza? So we see our conditional statement, test negative. And then do not have, that's going to be that 313.2. So I'm just going to take the 313.2, divide by the total for that column. To the nearest hundredth, I have 0.91. Okay, we test negative for, or I'm sorry, test positive for influenza. What is the probability that you don't have it? So now we're just looking at the positive test column because of the given condition. So, and then do not have, or does not have, so 208.8. And then we're dividing by the 255.6. I have 0.82. Okay, what is the probability a person will test positive for influenza? There's no condition here. So those first two, those have these conditions. There's no if or given uh like keyword to signal that it's going to be a conditional probability. So it's just a regular probability. So we just need the number of positive tests. So that's going to be this and then over the grand total. So 255.6 over the 600. Okay, to the nearest hundredth, that's 0.43. All right. Good luck on test four, everyone.